Hi everyone, in this video you're going to learn complete concept of factors and where we use these factors and how do we get factors of a number and what do we call factors in usual terminology. Alright, so the next video will cover about the concept of multiples. Hope you like the video. Okay, let's start. Okay, now what we have here, the definition of factors. You can call factors or the divisors. You can call this as divisors as well, because factors are nothing but a type of numbers which can divide another number completely. So I have selected n equal to 8 for an example. As you can see, I have given m the values between 1 to 8, and we are calling this m as the divisor of n or the divisor of 8, and we're going to check which numbers from this series is dividing this 8 completely, basically. So we are looking for an integer over here, in this case, which when multiplied with 1 will give you 8. So we can basically say that 1 is dividing 8 completely, because we are not getting any remainder left, as in this case. As you can see that some integer equal to 8, then multiply 1 into 8, you're going to get automatically that is equal to 8, and we get that n. So we consider this 1 right over here, m, as a factor of n or the divisor of n. Alright, so factors are nothing but which divides a number completely. Alright, I don't want to make you confused between the divisor and factors here, because the divisors are the basic term that we use in dividing something, but factors are more precisely used only when a number is completely dividing in a specific number. Alright, so moving on to the second case here, that if I take 2 over here from this series which I have selected, when 2 multiplied by 4, as you know that, will give you 8, and we are not getting any remainders left over here. So the remainder is equal to 0. The first case is also the remainder is 0. So in this case we consider this 2 is the factor of 8. So and one thing you can observe from here, that is 4 is also dividing 8. So we can consider 4 is also a factor of 8. Moving on to another number here, that is 8 equal to 3 into 2 plus 2. As you can see, we are getting a remainder that is equal to 2, and this 3 is not completely dividing 8, so we cannot consider 3 as a factor of 8. As you can see, we have 2 here in this case, and we have already seen that 2 is a divisor of 8. But if the case is like this, if 2 is getting multiplied by some number, that is 2 into 3, that is 6, you can see that 6 is not a factor of 8. 6 cannot divide 8 evenly. Alright, you will left some number, so that number is equal to 2. So you can say that. Now another example over here, that is we have already seen that 4 cross 2 gives you 8, and we consider 4 is also a factor of 8. And if you go on finding out the factors of 8, you're going to get numbers which can divide the 8 completely, consider to be we call them as factors. So here we have, you can check for all other numbers if you think that could suit this case, in this case, and the remainder should not be equal to 0. and you can take minus and plus values as well here. Alright, so by this we can have an assumption over here, that is factors of 8 will always be equal to that number. Factors over here will always be lesser or equal to that number. Alright, so we have factors here, that is 1, 2, 4 and 8. As you can see, all these numbers are lesser or equal to that n. Okay, so I have taken another example over here. In this case, I have selected 27 as n. Now I want to find the factors of 27. Factors are the numbers which can divide this 27 completely. So we have already know that the factors should be equal to or lesser than that number, that is that it should be lesser than 27, right? So we are starting from 1 over here, and we will see that when 1 is getting multiplied by 27, you're going to get 27, right? That is the answer. So 1 and 27 is considered to be a factors of 27, right? Now moving on to 2. 2 when multiplied by any number will not give you 27 exactly. So 2 is not completely dividing 27, so we are considering 2 as not a factor of 27. So if we move on to another number, that is 3, we are going on in a ascending order over here. So we have 3 multiplied by 9 will give you 27. As in the case of 3 and 9, we are getting 27, and we consider 3 and 9 both are factors of 27. So we basically got 1, 2, 3 and 4. We got 4 factors for 27 which are dividing 27. So yeah, we have got 4 factors for 27. Okay, what if we that is we can use, all right, LCM in order to find the factors of a number. All right, so LCM is nothing but we are finding prime factors of 27. So as you can see, I have got prime factors of 27 that is equal to 3 cross 3 cross 3. And now what you have to do is you have to make possible combination of all these prime factors and try to make another composite number from these. And in this case, we've got first combination, that is 3, and then we have another combination that is 3 cross 3, that is 9. We have got another combination over here, and then we have another combination that is 3 getting multiplied 3 times. We are going to get 27. So by using LCM, you can find the factors of any number, and you just have to keep that in mind. You don't miss any combination. All right, so and you know that 1 is the factor for every number. All right, and we have another support, I would say, in order to find factors of a number. All right, so you can use divisibility rules of a number. As you know that for example, I have given over here, that is, if a number is divisible by 3, then the digits of that number when sum up is divisible by 3. For in this case, we have got this 27 as that number, and we have to find out the factors of this 27. So what we can do, we can apply this divisibility rule over here. That is, we have to check by which number this 27 can be divisible or can be divided completely. So we know that number this 27 is not getting ended by an even number at the end, so we know that it is not divisible by 2. So you can check for divisibility rule for 3. Here when you sum up the digits, you're going to get 9, and this 9 is getting divisible by 3, so you can consider 3 as one of the factors for 27. So you can check for all divisibility rules and apply that rule, and you can easily get the factors of any number you want. So these are two methods you can use, but there is some kind of problem you might face while doing that. What if you miss some combinations, or what if you miss to apply some divisibility rule? So in this case, you should know something, right? For example, you should at least you should know how much factors could a number have at max. All right, we know that the factor will always be equal to or lesser than that number, but we don't know how many factors can a number can have. All right, so for that we have something unique over here. Okay, so for that we have a formula. I'm not going to discuss how we got this formula over here in this video, but just understand what it is going to do for you in finding the factors. Here, this a plus 1 getting multiplied by b plus 1 getting multiplied by c plus 1, and so on. Here a, b, c are the power of a prime factors of a number, and we know that the prime factors of a number, that is in this case we have 37, we got the prime factors. You can do this in this way as well. You get the prime factors and you make the power of these prime factors, and you got the power of that factor of a prime factor that is equal to 3. In this case, you just substitute 3 in the place of a. What if you get a different combination over here? For example, if I take 24, for example, you might get 2 into 3, that is the factors of what if you take 24, you're going to get the factors like 2 into 2, 4 into 2 into 3, 8 3 is 24. That is what we get. Alright, so as you can see, you got a different prime factors. So if you club them up, you're gonna get 2 power 3 into 3 power 1. Alright, so we have in this case here b equal to 3, b equal to 1, because we are dealing with factors of different primes, power of different. Okay, so as you can see, when I applied the formula a plus 1, that is a, in this case we have 3, a power of a prime factor, you're going to get 3 plus 1, that is equal to 4. And we have already got to know that 27 has 4 factors. So we got the number of factors, and by using this formula you will get the brief idea how many factors you have to find out, or if you might have missed any factor, you can get from this you can get the idea from this formula. All right, so apart from that, we have another type of formulas that could help you. These are product of factors. You can use this formula in order to find the product of all the factors of a number. That is n. N is the number which we are working on, to which we are going to get the product of factors, and we have number of factors. You can use this formula to get the total number of factors and divide this by 2, and you will get the product of factors of that number. And we have sum of factors, the formula for that, this one right over here. For example, in the previous case, you've got that is 3 power 3 for 27, the prime factors. So you have one type of prime number. So these P and Q then R are type of prime factors, different type of prime factors. If you have only one type of prime factors, you can use this. And if we substitute 3 and we have the power of 3 that is equal to 3, so what you have to do is you have to start it from like this: 3 power 0 plus 3 power 1 plus 3 power 2 plus 3 power 3, and try to solve this. You're going to get the sum of factors. So this is pretty much we have. Now one thing that I want to add up that you can find a number of even factors or number of odd factors by using the same formula that is we have here: a plus 1 into b plus 1 or c plus 1. You just have to exclude even numbers, even prime numbers. That is, in this case we only have even prime number, that is 2, we know that, and every other prime numbers are odd numbers. So we just have to exclude the 2 prime powers. So you're going to get automatically the even or the odd factors of a number. It depends. Now we have a divides b. It is saying that a is dividing this b completely, so we can say that a is a factor of b. All right, so in the next case, b is dividing c. B divides c. You have to say it in this way: b divides c. So this implies that a divides c. You can see over here, right over here, that is a is a factor of b. All right, and b is the factor of c. You got to know that. And we can say that a, as b is the factor of c and a is the factor of b, so that automatically a will also be the factor of c. And you can say that by multiplying a with some number, you will eventually get b, and if you do multiply even more, at some point you're going to get c as a factor, as a multiple of a. So yeah, a is a factor of c in this case, and a is a factor of b in this case, and b is also the factor in this case of the c. Now we have another example. For example, a is dividing b and a is dividing c. All right, so the assumption says that a should divide b minus c, or a should divide b plus c. So we are saying that a is a factor of b and a is a factor of c, and we are also saying that a is the factor of the number which is the subtraction, which is the okay, we can say that a is the factor of b minus c, and you can say that a is also the factor of b plus c. You can see the example right over here, that is, if I take a is equal to 3 and b equal to 9 over here and c equal to 97. Now I'm using this generalization over here. 3 divides 9. We know that 3 is a factor of 9 because 3 is dividing the 9 completely. Whenever a number is dividing another number completely, we call this number right over here a factor of that number. Alright, so 3 is a factor of 9, 3 is a factor of 27, so that means 3 is also the factor of 9 plus 27, that is 36. So this is what we have. 3 divides 36, right? Okay, as in this case, we can say that 3 also divides, that is 9 minus 27, that is minus 18 you're getting. So minus 18 has a factor 3, and we know that it goes with -6. 3 minus 3 getting multiplied by -6 will give you -18. And we have some uses as well over here where we use factors mostly. So now this is what we have pretty much about factors, and in some other video I'm going to cover about the concept of multiple, and I believe I have covered everything related to factors. And if you think that if I miss anything related to factors, you can have the doubts or questions in the comment section below. Okay, thanks for now.